In this video, we will begin our midterm review. So we will be doing review problems from chapters 1 and 2. So we'll do a chapter 1 and 2 practice problem, and I'll do that in this video. So in this video, we'll review stuff like revenue, cost, profit, supply, and demand. And in later videos, we'll do some limit practice problems and some definition of the derivative practice problems. So today's lecture videos are not intended to be a comprehensive review of every type of problem that could show up in the midterm, because there's no way I could fit that all in a single day. Instead, all the problems I'm going to be doing are questions that I feel would be good practice problems for the exam. All right, so let's get into our first example. All right, so this is one of the questions from our midterm practice problem. So it's problem number 7B from the midterm practice. So the scenario is, suppose that when Fred and George charge 7 sickles for extendable ears 1 month, 600 people purchase one. When they increase the price by 3 sickles the next month, 90 fewer people purchase one. Suppose the demand is linear. And also suppose that extendable ears cost Fred and George 3 sickles each, plus 1,000 sickles in monthly fixed costs. All right, so I want to do just part B of this example. So part B is asking, repeat part A, but now suppose the supply function is this formula here with a square root. What was part A asking? So it was giving us a different supply function, and it asks, what is the price at which there is no shortage nor surplus? So I want to give you all the opportunity to try these practice problems, particularly today, because they're for our midterm review. So pause the video for about 3 minutes and try this question. So 4, 3, 2, 1, pause the video. Pause the video and try this for 3 minutes. This is a really good practice problem. I think something like this could certainly be a good midterm question. So it's good practice to see how well you can do with it right now. All right, hopefully you've done that. Hopefully you pause the video for about 3 minutes to try this. If not, seriously, go ahead and pause the video now. I highly encourage you to do that. This practice is going to be really valuable. Okay, so let's talk about it. So the question is, at what price is there no shortage nor surplus? So what does the fact that there's no shortage nor surplus mean? Well, this means that the demand and the supply are equal. Because if we had more demand, if more people were demanding something than it was being supplied, we'd have a shortage. If we had more supply than people wanted it, than people demanded it, we'd have a surplus, we'd have extra. So they need to be equal. And when they are equal, this is called equilibrium. So that's what this question is asking us to find, actually. When does equilibrium happen? Well, so to answer that, we need the demand and we need the supply. And in part B, we're given the supply, so we need to find the demand. So if we look at the information that it gives us, this problem gives us a couple of P, Q values, so price and demand values, that I can put into a point as coordinates. So it says that when they charge 7 sickles, so when the price is 7, so by the way, sickle is just currency in the Harry Potter world. So when the price is 7 sickles, the quantity that's demanded is 600. That's the monthly demand. Okay, but then we also have information for another point, for another P value and another Q value. It tells us that when they increase the price by 3 sickles, that means the new price would be 10 sickles, 90 fewer people purchase one. So instead of 600 people purchasing one, there would be 510, okay, that month. So that's enough information to get an equation. So using my slope formula, the slope would be 600 minus 510. So change in Q, in this case, on the top, over change in P on the bottom, so over 7 minus 10, simplifying, this is negative 90, sorry, no, positive 90 divided by negative 3, which is negative 30. So that's my slope, negative 30. And now let's write down the equation. So the equation is going to be q minus a certain coordinate equals the slope, negative 30, times p minus a certain coordinate. Okay, so for these coordinates, I can pick any point that's on the line. So let's just say that I pick the first point. So the q coordinate is 600, so that goes after this minus sign. And the p coordinate is 7, so I write p minus 7. All right, so I'm using point slope form here to get my equation. All right, so we have q minus 600 equals, distribute the negative 30, and we get negative 30p plus 210. And if I isolate q, we get q equals negative 30p plus 600 added to 210 is 810. And that's our demand equation right there. Okay, so let's zoom out a little bit so we can see the supply. Okay, so now if we plug in the demand and the supply into this, we end up getting, so the demand is negative 30p plus 810. And that's going to be equal to the supply, and the supply is square root of 12 minus p minus 31p plus 820. All right, so we have this equation that we need to solve. Okay, so at this point, if you didn't quite get this far, when we pause the video for that first 3 minutes, pause it one more time and try it for another 2 minutes and see if you can finish the problem from here. 4, 3, 2, 1, pause the video. Pause it for 2 minutes this time and see if you can take it from here. It might not be enough time to finish the whole problem, but see if you can remember what the key ideas are for taking this further. All right, so hopefully you've done that. Hopefully you paused it for about 2 minutes to try this. So when we have an equation with a root, we want to isolate the root. So we want to isolate the square root. And once it's isolated, then we can square both sides. So that's going to be our strategy here. So I'm going to add 31p to the left. And when I do that, 31p minus 30p is just p. And then 810 minus 820 is minus 10. Okay, so that simplified quite a bit. That's nice. All right, so this equals square root of 12 minus p. And now that it's isolated, we can square both sides. So we have p minus 10 squared equals root 12 minus p squared. On the left, we FOIL. So this is p squared minus 20p plus 100. On the right, we get 12 minus p. Okay, so this is a quadratic. We can handle these. Let's move everything over to one side and then try to factor. So we get p squared, adding p, we get minus 19p, subtracting 12 plus 88 equals 0. Okay, so we got a quadratic. Typically at this point I try to factor it, and if it doesn't factor, that's usually where I would personally go to the quadratic formula. So I'm going to try to factor it first. Because if it does factor, that's usually quicker than going the quadratic formula route. So this factors is p, and then I need two numbers that multiply to 88 that add up to negative 19. And it turns out what works is negative 11 and minus 8. So we get p equals 11 and 8. So are we done? Are those our answers? 11 and 8? So it turns out not quite yet. There's a little bit more to do. So let's talk about that. So when we have an equation like this that has a square root, or in general, it can be any even root, like a fourth root or a sixth root, once we get our answers, we need to check for extraneous solutions. So that's what I still need to do. So when we check, I'm going to plug it in to the equation at a point when it still had the square root. So I'm going to plug into this step right here. All right, so I've just gone up to the top of the page to give myself more room, and we need to now check for extraneous solutions. So our two answers were 11, so we need to check that, and the other one was 8. And we'll have to check that. So hopefully I'm giving myself enough room to do this, but if not, I'll move this. So if I plug in 11, we get 11 minus 10 on the left equals, I'll put a question mark above the equal sign because I don't know if they're equal just yet. 12 minus 11 inside of the square root on the right. So 11 minus 10 is 1, and then square root of 1 is 1. So 1 does equal 1, so that one works. 11 works when we plug it in. If I plug an 8 into this, we get 8 minus 10 on the left. Put a question mark above it because I don't know if they're equal just yet. Plugging it in on the right, we get 12 minus 8 inside of that square root. So 8 minus 10 is negative 2. On the other side, we get square root of 4, which is positive 2. And those are definitely not equal. So we're a bit sad by that. That one didn't work. But all that means is this answer, the 8, we put a slash through it. That is extraneous. So I just write EXTR to abbreviate extraneous. So the question wanted to know what was the price that made this all happen. And it turns out the price that works is $11. $11 is the price at equilibrium, the price at which there's no shortage and no surplus. Okay, so in terms of our goals for this section, our review section, we have done an example from chapter 1 and chapter 2. And again, like I mentioned at the beginning, there's no way that in one day's worth of videos I can review everything. I'm trying to pick just a bunch of problems that I feel like would be good practice. So in this problem, we practiced things like supply and demand. But there are other topics from chapter 1 and chapter 2 that I don't have time to review in today's review video. So things like revenue and cost and profit and interest. Definitely make sure you do some of the practice problems from our midterm practice problems on those topics. All right, so in the next video, we will do some limit practice problems.